By the end of this video, you'll understand the 4 pieces every working AI agent needs and why most agents people are building right now will quietly fail in production within 30 days. I learned this the hard way running 14 agents across my businesses. Most people think an AI agent is just ChatGPT in a loop. That's not even close. A real agent is 4 distinct systems working together, and if any one of them is missing, you don't have an agent. You have an expensive chatbot that hallucinates expansively. I've been running production agents across 4 businesses for 18 months. Here's the actual architecture, the parts nobody explains, and why the gap between a demo and a working agent is bigger than you think. Let's get the definition right, because this is where most tutorials lie to you. An AI agent is a system that takes a goal, decides on actions, executes those actions in the real world, observes what happened, and adjusts. On the keyword is the on a relay real world. Number 1, if it can't touch anything outside the chat window, it's not an agent. It's auto-complete with extra steps. In my company, Ame, I run agents that post to Facebook, query my Postgres database, send emails through Gmail, and trigger video renders. Each one of those is a real-world side effect. The agent has to know which tool to pick, when to pick it, and what to do when the tool fails, because tools fail constantly. That's the part the demos hide. So when somebody shows you a flashy demo of an agent booking a flight, ask one question: did it actually charge a credit card? If no, you watched a simulation. The leap from simulated action to real action is where 90% of agent projects die. The brain of an agent is what's called the react loop. React stands for reason plus act. The model thinks, then acts, then observes the result, then think again. This was published by Google Research in 2022, and it's still the foundation of basically every production agent today, including LangGraph, CrewEye, and Anthropic's own agent SDK. Here's the loop in plain English. Step 1. The model reads the goal and current state. Step 2, it generates a thought. So quite literally a sentence like, I should check the user's calendar before suggesting a time. And step 3, it picks a tool to call. Step 4, the tool runs and returns a result. Step 5, the result gets appended to the conversation and the loop starts over until the goal is met or the agent gives up. The non-obvious part is that the thinking step is critical. If you skip it and just let the model pick tools directly, accuracy drops by about 30% in benchmarks. The thought forces the model to plan before acting, which is exactly why human engineers write design docs before writing code. But so, same principle on lot solve, tools are how the agent touches the world. In technical terms, a tool is a function the model can call by emitting a structured JSON object that names the function and supplies arguments. Anthropic, OpenAI, and Google all support this through the same pattern, and the Model Context Protocol, MCP, is the open standard that's emerging to make tools portable across providers. In my local AI hub system, I have about 40 tools registered. Things like search directory, qualify leads, send follow-up email, log to Supabase. Each tool has a name, a description in plain English, and a JSON schema describing its arguments. The agent reads those descriptions and picks. The descriptions are the actual API to the model. If your tool description is vague, your agent will misuse it constantly. The single biggest mistake I see is people giving agents too many tools, past about 20 tools. Accuracy collapses because the model can't keep them all in working memory. On the fixes, hierarchical tools, a router agent that picks the right sub-agent, which then has access to a focused tool set. That's how Claude Code itself works, and it's how I structured every OM MAE agent after the first one melted down at 30 tools. Memory is where almost every hobbyist agent fails. Large language models are stateless. Every API call is clean slate. If you want the agent to remember what happened 10 minutes ago, you have to engineer that yourself. There are 3 layers and you need all 3. First is short-term memory, which is just the conversation history packed into the context window. Cheap, simple, but it caps out at whatever your model's context limit is. Second is working memory, a scratch pad where the agent writes intermediate results. I store this as JSON in a Postgres table indexed by session ID. Third is long-term memory, which is usually a vector database like Pinecone or pgvector, where past interactions get embedded in tree by similarity when relevant. And the trick nobody talks about is memory hygiene. Agents accumulate garbage fast. If you don't summarize and prune, the context window fills with noise and accuracy drops. In I run a small cleanup agent every 6 hours that compresses old memory into summaries and archives the rest. And without it, my Mohawk Medable support agent started giving worse answers after about 2 weeks. With it, it's been stable for 10 months. The fourth piece is what separates a toy from a production system, and it's almost never covered in tutorials. Real agents fail constantly. APIs time out, tools return errors, the model picks the wrong action, network drops mid-request. If your agent doesn't handle these gracefully, it'll burn through your API budget in an afternoon. The pattern I use is borrowed from how Stripe and Shopify handle webhooks. Every tool call has 3 states: pending, succeeded, failed. Failures get retried with exponential backoff up to 3 times. After 3 failures, the agent gets the error back as an observation, and it's allowed to either pick a different tool, ask for human input, or abort cleanly. Critically, every tool call is logged to a database with a unique idempotency key. So if a request gets duplicated, the second call is a no op. The other piece is human in the loop. For anything that costs money, sends a message to a real customer, or modifies production data, my agents pause and require approval. I use a Telegram bot for this. The agent writes, I want to do X for reason Y. Approve, and I tap yes or no. This single pattern has saved me from at least 4 production disasters in the last year. So here's how to actually build one. Start with a single goal, narrow scope, pick a model with strong tool use, Claude Sonnet 4.6 is what I use for almost everything because the tool calling is reliable. Define 5 tools, no more, with crystal clear descriptions. Add a Postgres table for working memory. And add retry logic with exponential backoff. Add a logging table so you can see every thought, action, and observation after the fact. Add a human approval gate for anything irreversible and for framework choice. So, and if you're new, use the Anthropic Sigma E-level agent SDK or Lang graph. If you want full control, write the loop yourself in about 200 lines of Python. I do both depending on the project. For production, I lean toward writing it myself because frameworks add abstractions that hurt when you're debugging at 2 a.m. The whole point is that an agent isn't a magic AI thing. It's a regular software system that uses a language model as one component. Treat it that way and you'll build something that works. Treat it like a chatbot and you'll burn 3 months on a demo that never ships. Which part was most useful? Let me know in the comments. And if you want me to break down how to build the human-in-the-loop approval system, specifically, drop a comment and I'll make that the next video.